Well guys, it's Matt here. We're finally getting around to rebuilding this. It's a Hitachi alternator. Now the rear bearing is kaput, so this is a new one that's got to go in. I don't think it's done enough damage to make the rest of it unusable, so hopefully just two new bearings in and that'll be right to go. But I will also show what can be done and how you can test a couple little things. In a previous life, I was actually an auto electrician and I did quite a lot of rebuilding starters and alternators. Hopefully I won't do too much dodgy stuff today, but just some good information for anyone that's interested. First things first is we want to whip this apart. Now, easiest way to pull the pulleys off, with most alternators that is just a rattle gun. Make sure you got the right socket, and you just hold the pulley, get it on, and she should pop straight off like that. And always put your parts in one spot. So we've put a mark in here just to make sure when it goes back together we don't get anything around the wrong way. And then we've got to go and pull these 4 bolts along the outside here. Some of them come from the front, some come from the back, but generally there's 4 long bolts that go right through. Sometimes they're just a Phillips head, or sometimes they're a hex head. Yeah, it's a lot nicer when they are a hex head, so you don't strip them out. Righto, now the next step, once we've got all those out, is we've got to put it in the vise. Now, some alternators have a brush holder that goes straight in from the back. Now actually this one I pulled apart earlier does. So this is the back housing, I've already pulled it apart, but the brush holder sits in there like that. This is a Bosch alternator, quite a common one for older tractors and cars, in Australia here anyway. So yeah, just make sure you pull that one out first, otherwise you'll snap the brushes off. And yeah, so but this one doesn't. This one's got the brushes inside, so you can't access them without pulling it apart. So you sort of got to hope for the best a little bit. But we get one lug on the front housing, so that's the housing that's closest to where the pulley goes, in the vise. And we want to tap around the edges, being fairly careful not to dent anything. We don't want to dent the stator. Otherwise, yeah, it can push the little staples that's all made up of in and potentially hit the rotor when we go put it back together. So, don't need a too big a hammer, just a regular hammer is fine. And we just tap along the edge in a few different spots, and we'll see if it comes. If it doesn't, we'll move to plan B. So, we've got that apart. Now what we also want to do is just have a quick look inside, because if we've got any markings in here where you can see metal's been hitting on the stator inside here, it's alright if it's been brushing it, but if you can actually see some little segments have moved, then it's probably just a throwaway job. But this one looks fine, because the rear bearing here was on its way to failing. Yeah, that can be an issue. If that starts flogging about, then the rotor can hit in here and cause some issues. But I think we're all good to go here. We've still got a decent amount of brush length. It'd be probably nice to have a little bit more, but we've probably got 7 or 8 mils of brush length there, so this will be fine just for a backup alternator anyway. That should still have plenty of life left in it. Now what I will do is we've got to get this rotor out of this front housing. So a quick way, hopefully, is you can just put it in the vise with it. Sometimes you have to use a press, but a lot of the times you can just do this. Now just make sure it's not fouling on anything, and just don't tighten it up on the rotor, so make it so it sort of can move about a bit, but make sure that yeah, the rotor's not hitting underneath anywhere. What we also want to do is put the pulley nut back on. Now we just want to put that on so it's flush, and that saves us potentially damaging it. Ideally, you want to use a soft blow hammer, but if you're careful enough, you can use like a brass drift or something, yeah, to knock that through. So we can see there it just started to come. Now we just support the base of the rotor with your hand. Tap that through. There we go. So we've got the front housing off and we've got the rotor out. Now there's some of them will have a little spacer there. Just take note of that and put it away so I don't accidentally lose it. Now what we'll do first is pull this bearing off. Now if you've got a special bearing puller, that's fine, you can use them. There's got a little hole in the bottom there where it can line up and it's all good. What you do is you get it in the vise. Now you can see that on the face of the vise here, I've just got it in a little bit further than that where I want to get it underneath. Now don't be too afraid to tighten these right up. Obviously don't go silly, but make sure that's in there nice and solid. And what you want to do is get 2 pry bars, so you can see these ones have got the little angle on the end, and you get that in there like so. Now we lever off those edges of the vise and then just give them, at the same time, give it just a nice, quick, strong push. And another thing you can do is, just for the sake of not everyone has a lathe, we can just put that in there just fairly roughly, make sure it's not going to slip out. But we'll pop that in here and then you get a drill. So we've got the drill, and what we want to do is we just want to put that over the end like so and tighten it up. And again, you don't want to overdo it as to mark where the bearing sits. But if you do, you can always just file that back later. And we want to grab some emery tape. Now, if your slip rings here are got a massive groove in them, and yeah, they look, you can get sort of your fingernail caught in there, it means you probably do need a lathe. I mean, in an emergency situation, you'll be right, but to do it up, you really need to machine that down as long as you've got enough material left there. But this is quite smooth, so we can just get away with the emery. So you can see that's nice and shined up. There's a couple of little marks in there, but that won't be an issue. So I'm going to have to just file this off a little bit. There's a little lump there. I forgot that this drill has a bit of an issue with its chuck. But what you can do to stop this is just wrap a bit of electrical tape around that before you put the drill on it. That would have been a great idea. Good idea to check before we get too far ahead is we want to check the resistance in the rotor. Yeah, all you do for that is you just put one on each slip ring, and the multimeter is saying about 2.4 ohms. So if it's an open circuit or that, yeah, obviously you've got issues, and again, it's probably a throwaway job. Other thing, quick test to do is just go onto the metal of the rotor and onto the slip rings. Make sure you don't have any continuity between them. If you do, that means you've got a short in the coil going to the earth, which again means it's virtually stuffed. We now have the rear bearing off and slip rings tidied up, so that's ready to go. If you want, you can put these in a parts wash, just everything once it's fully stripped. I've still got to pull this bearing out here, but yeah, you can get it all nice and clean in a parts wash, but you just got to make sure you wash it out and dry it quite well. But yeah, there's not really much you'll hurt. Now this is just a spare alternator, so I'm not worried about how it looks. You can even sandblast the housings and paint the stator and do whatever you want, but I am not going to be doing that. So if you get this on something solid like that, you do have to be a little careful if it's not coming real well. Sometimes you have to find something to support it under there. Generally speaking, you're pretty right. So we've got that out. That's the old bearing. Because I'm actually not going to really touch anything on this alternator, other than I might give it a quick blowout. What I'll do is most alternators are the same or very similar, and you can sort of use the same methods of testing them as others. So what I will do is I'll put that one aside because it's virtually ready just to whack that all back together. I'm only doing bearings on this one, like I said, but I'll come over to here and show you this one. So this alternator, again, it's a little bit different, but same sort of concept. Now, once you pull the back housing off, this is what you're left with. So this is your stator, and then you've got your rectifier here. Yeah, so your regulator, which is this one here, is what determines how much power goes through the rotor, which then determines the voltage, the AC voltage of this, the stator. So then that AC voltage goes into the rectifier, and then you've got 6 diodes in here. Most alternators have about 6, and that then converts it to DC power, which is what your cars run off, or tractors, whatever. So what if it wasn't charging beforehand and you're trying to work out what the go is, the first thing to check is your brushes, make sure they're making contact. Second thing to check is your rotor and make sure it's no short, there isn't a short there. Next thing to check is you pull this all apart. Now there is some insulators and things on some of these bits that you need to take note and make sure they go back. But what we have here is a positive plate. You can tell that because you've got your positive terminal sticking out from there. So that's your positive plate and that's your negative plate. Now this just bolts onto the back housing, so you can also tell that that's the negative plate. Now there's 3 diodes, that's those things there. And what we're going to do to test that is we're going to disconnect the stator. Now this is just soldered on to the rectifier. So if you get a good soldering iron, and just got to be a little careful with the wires. I'll whack it in the vise here. You've got to be a little careful, don't want to get too carried away with that. And we carefully add a bit of solder in there, it just helps get the heat into it. And once that starts melting, the solder, you can just flick that out. And we'll do that to the other 2. Righto, so we now have the rectifier off. Now again, good thing to check is get the multimeter, and we want to just check that this is not shorted out. So the main thing we want to check is that we don't have any continuity between the windings in the stator and the housing of the stator. So yep, we're all good there. Now another good test when you come to try to test these diodes, one of the easiest ways, and anyone can do it. So what you do, or what I've done, is quickly just jigged up this. I've got an old battery and got this light wired in so that when you touch these together, the light comes on. So it's a pretty simple circuit. Should be able to work that out. What we want to do is we want to put one side. See, the purpose of a diode is it only allows current to flow one way, and if that's not working, then the alternator, it doesn't charge properly and you have other issues. So what we want to do is we'll put one to the positive stud. So that's essentially connected to the positive plate. And then we want to go here, and where I took the stator off, so the 3 different points where I unsoldered the stator, is you want to put it on each one. Now this shouldn't light it up. If it does, then we've got an issue. But if I swap that around, put that on the positive stud, and do it again, it should light up. So 1, 2, 3. Yep, so that's good. The positive diodes are fine. Now we do the same thing with the negative. So just put it to anywhere on the plate really, and do the same thing. So nothing, nothing, nothing. Swap that over. Light, light, light. Righto, so we know the diodes are good. Now I'm not getting overly technical, but that is a good general indicator whether you've got an issue or not. Again, this is just an old alternator. This isn't the one I'm actually pulling apart, but that's a quick example of how you can check, just to make sure you don't pull it all apart, put bearings in, and then all of a sudden find out, oh, you've got another issue. So that is the purpose of those brief tests. We should be right to go with this. Now another thing, you just check that you've got good spring in your brushes there. Make sure they're not jamming up, because that's another issue that can happen. If they don't have positive contact onto the slip ring, you can have one of the biggest indicators of that is a flickering warning light on your car or tractor or whatever it is. If the warning light's flickering, that's a good indicator that the brushes are either worn right out or jammed or something. And that's probably not so common with the newer vehicles, because the battery light works differently to these older type alternators. But if you do see that, it's a good indicator that it's probably brushes. Whack this back together. Now, because the brushes are on the inside of these, whereas on that other alternator I was showing you, it just goes separately on from the outside. Makes it a little easier that way, but these ones are a little bit more tricky when you go to put them together, because you can see the bearing sits down there. If I just try to jam that in, it's going to snap off those brushes. So what we do is you find probably the easiest thing, if you've got a paper clip or something, you can straighten it out. But also what you can do is get a little drill, as long as you don't lose it. And you can see in the back here there's a hole, and that is what you're meant to do. Is I just put a bit of weight on it with my finger, just push against it, and then I get a little right angle pick and push those in like that. You can see the brushes are no longer sticking out, and yeah, that is there. I'll just pull that out after it's assembled. So I'll leave that aside for the minute. Now we can pretty easily and quickly whack this bearing in. Now it is a good idea just to use a screwdriver for these, not a impact gun, but I don't often listen to my own advice, so I'll just be careful. It is good just to make sure, give it a little tweak with that, make sure it isn't loose. Righto, that's good. Bearing spins well. Now what we'll do is put that in here, close it up. Again, you can get fairly robust with it. Now what I'm doing here is we just want to make sure that is touching the bottom of the vise. So you've got, because we're going to be hitting the bearing on here, we don't want it to be sliding in the vise here, otherwise you can just put some grooves in that. But yeah, we'll get the bearing and whack it on. Just want to be quite gentle with these ones. The inner race of this bearing is quite thin, so it is quite easily to damage. Bang that on like that. That's that done. Now, again, we want to flip this open, sit that at the bottom. We want our little spacer in there, and this here. Now, what we'll probably do is get a deep socket that can slip over the shaft, but hits on the inner race of the bearing, and that way we won't damage it. So you just want to line up the screws, and we can even throw 1 or 2 in just to make sure we're not out of line. Alright, so it's all fairly well seated. Now put the rest of the bolts in here. Now I will listen to my own advice. Do not use an impact or rattle gun for these bolts here, because you will strip them, and that is very annoying. Now you should feel it when it's seat, but you can hear it just creaking there. So what we want to do, again, just the hammer, just means it probably hasn't quite seated in the bearing here. We'll just relieve a bit of pressure and do it again. Yep, so that's tightened up there now. That's tightened up, that is tight. Righto, now we can pull this pin out, or drill bit, and we're done. And you want to check, spin it, and check that it's nice and smooth. This one feels good. If it's a bit stiff, again, sometimes you just might have to relieve a bit of pressure in the back bearing here, so you just give it a few taps with the hammer, and it should loosen up. So yeah, that's it, all good to go. Well guys, a little bit of bonus footage. This is a alternator test bench. I've had for a few years now and probably used it 3 or 4 times, but it is handy in these sort of situations. Alternators are all wired up differently, and the plugs on them are different. A lot of these sort of ones have an L terminal and an S terminal. The S stands for sense, and what that is it just is battery power. So it's actually what the regulator in the alternator uses to determine how, well, what voltage it should put out. Now the light is, as I was explaining before, is usually connected to your warning light on your dash, and it it actually puts power to the alternator, and then obviously when the alternator is charging, power comes back, and that's why your light goes off, because you've actually got power on both sides of the light, which means there's no voltage between the two. Thankfully this has got a little diagram of which wire's which on this plug, so I can just, I don't have to sort of guess, but I'll just put that sense wire just straight onto the battery positive there. Now this wire here is the warning light. Righto, so we've got our warning light on. Now we should see the warning, when I turn this on, we should see the warning light go out and the volts here jump up. So it's on a bit over 12 there now, so we should see that jump up, a fair bit there. So we will flick this on, speed it up. There we go, so the warning light went out. Voltage is gone up, and we can see that the voltage is actually staying still. If that was to just keep going up, then obviously we'd have a regulator which is stuffed, but that is sticking pretty well smack on 13.5 volts, I think, but these gauges are a little bit out anyway, but it's just more of a relative thing. So we've got this running here now. What we can do is load it up. So we've got different loads here that we can load it up on each of these switches. So that's 40 amps. Now this is a 90 amp alternator, so no real need to load it up much more than 40. So we'll speed her up. We can have a look at the voltage. So we can hear it load right up. Voltage is still up there. Everything's going okay here. So those how we load test it is just old bulbs all wired in there. So I can actually put more in if I want to, but yeah, there's no real need. It'll just probably spit the belt off, and yeah, it won't be real fun. So we'll turn those off, and we'll have a look here. Flick this off, you should see the warning light come on. There we go. So that's it, this one works fine. It's not the usual content we put out, but if there's something of interest and people might find interesting, I'm happy to yeah, throw something up, and yeah, hopefully it helps out people. If you enjoyed it, just hit the like and subscribe if you haven't already. So anyway, it's working.